Hi there! In this video we are going to learn how to do basic modeling in Houdini. We are going to create a few meshes using the Extrusion Modeling Technique, and we are also going to deform a mesh by editing its points and also using a deform tool. I hope you feel comfortable navigating in the viewport and selecting objects and components, and for efficiency get used to the shortcuts instead of the standard methods. When you hover over a tool or display a menu, Houdini shows you the existing shortcuts. For instance, for selecting geometry or components, instead of going to the geometry selection mode, then click on the selection tool and finally click on the component type, to select it's easy to press 1 for objects, 2 for points, 3 for edges and 4 for primitives. To change to select mode, press the S key, and for temporarily change to select mode, hold S, make the selection and then release the S key. Though I'm going to use the long method, please feel free to use the shortcuts instead. Okay, let's start. Extrusion modeling is a common technique to build meshes, and using an image as a reference helps to speed up the process. Go to the viewport layout options and select two views side by side. On the left side, set the view to front. Now, to load and display a background image in the viewport, go to the display options, or just press D. Now, go to the background tab. By the way, here you can change the viewport from light to dark. Leave the default light. Okay, to select an image to display, use the Select File button and select your image. And check Autoplace Image. Now you can use the image scale fields to adjust the size and the image offset fields to adjust the position. Close the display options window. Let's create a circle as our base. Control-click on the circle tool. Hold Ctrl and rotate the circle 90 degrees in the x-axis. Rename the object as base. In the operation controls bar, reduce the radius to 0.5 and increase the divisions to 96. Save the scene and give it a name. Activate the geometry selection mode and use the select tool to select the circle primitive. Now go to the polygon tab and click on the Poly Extrude tool. A node named PolyExtrude1 has been added to the circle. This tool can extrude polygonal faces and also edges. In the Parameters tab, you can control the distance and the inset. In the viewport, you can also use the handle to control the distance. Besides, with the heads-up display sliders, you can also control the inset and the distance. Set the inset to 0. If you rotate the view, you can see there is no back polygon. In the Parameters tab, you can check the option Output Back. Now you have a back polygon. Okay, adjust the extrude distance to match the reference image. To repeat the last instruction, PolyExtrude in this case, just press the Q key. A new node named PolyExtrude2 has been added to the network. To match the image, we don't need to modify the distance, but the inset. Okay. Let's continue. Press Q again and you have a new node named PolyExtrude3. Change the distance to match the image reference. We don't need to change the inset. Again, Q, change the inset. Q, change the distance and the inset. Q, change the distance. Q again, change the inset. We are going to skip the next section, and later, to shape this section, we'll be using the new beveling tool in Houdini 18. Let's continue. So, Q again, change the inset. Q, change the distance. Q again, change the distance. Q, change the distance and inset. Let's continue using Q to add PolyExtrude nodes and adjusting the distance and inset as needed. Okay, the base is finished. We are going to model the mid-ring as a separate piece, but instead of creating another circle and adjust its size and position, let's use the top primitive of the base as a starting point. The primitive is already selected. Go to the Modify tab and click on the Extract tool. Go to the object level. A new object has been created. Rename it as Ring. If you uncheck the display flag on the base object, you can see the ring object corresponds to the extracted primitive. Double-click to dive inside the ring node. Now press E for scale. An edit node has been added. Reduce the scale slightly. OK, we did this because the ring size is slightly smaller than the base. Make sure the primitive is selected and go to the Polygon tab and click on the Poly Extrude tool. Adjust the distance. Q to repeat the tool and adjust the distance. And once again Q and adjust the distance. OK, but the size doesn't match the image reference. Let's go back to the Edit node and adjust the scale. Better. Go back to the object level. Now, the top part is also going to be modeled as a separate piece, but using the top primitive from the ring. Activate Geometry Selection mode. Click on the Select tool and select the top primitive. Go to the Modify tab and click on the Extract tool. Now, go to the object level. A new object has been created. Rename it as Top. If you uncheck the display flag of the ring object, you can see the top object corresponds to the extracted primitive. Double-click to dive inside and make sure the primitive is selected. Now press Z and reduce the size of the primitive. OK, now go to the Polygon tab and click on the Poly Extrude tool. Adjust the distance. Continue using Q and adjusting distance and inset to follow the image reference. OK, go to the object level. From the shading view options, select Smooth Wire Shaded. Let's add some detail. Select the top primitive. As Poly Extrude was the last instruction, just press Q to repeat it. Adjust the inset. Q again, adjust distance. Q, adjust inset. Q again, adjust distance. Make sure the primitive is selected and deleted. Go back to the object level. And check the display flag on the base and ring objects. Let's continue adding detail. Select the inferior edge loop. Use the C key to display the radial menu and select Model, Polygons and Polybevel. Start adjusting the distance and now we have the required shape. Go down to the fillet section and adjust the divisions to 16. By default, the fillet profile is round and convex. Now, in Houdini 18, you can adjust the convexity, a nice new feature. OK, go to the object level. Let's add some detail to the button using the Poly Extrude tool and using Q to repeat the instruction and adjusting distance and inset as needed. Now, let's add some detail to the ring. Select it. Go to the Geometry Selection mode and select one polygon. Now hold A and middle mouse click on another polygon to select the loop. Go to the Polygon tab and click on the Poly Extrude tool. This time we don't want to extrude all the polygons as a whole, but to extrude each polygon individually. So, instead of connected components, select individual elements. Adjust the inset amount. Press Q to repeat the instruction and adjust the distance and the inset. The general shape is okay. Now let's add more detail by beveling the sharp edges. We could select the edges and go to the shell dock and use the tool, but it's faster and more efficient to do it in the network editor. Let's try it. Double-click on the ring object to dive inside. Now click on the output port of the last node, then press Tab and start typing poly bevel. As soon as the tool is filtered, press Enter. Check the display flag on the poly bevel node. If we set a value for the distance, all the edges are beveled. We don't want that. To exclude edges, open the exclusion menu and check the Ignore Flat Edges option. Now you can increase the maximum normal angle to exclude more edges. With 30 degrees, all coplanar edges are not beveled anymore, and that's what we want. Let's also change the divisions amount to 3. Okay, now let's also bevel the base and the top objects. But you don't have to repeat the process. As our bevel node is set, just select it and Ctrl+C to copy the node. Go to the object level. Dive inside the top object. Go to the end of the network. Press Ctrl+V to paste the bevel node and connect the last output port to the input port of the poly bevel node. The top object has been beveled with the same settings we use for the ring object. As needed, you could change the parameters. Now go to the object level and do the same for the base object. Dive inside, go to the end of the network, Ctrl+V and reconnect the ports. Okay, these 3 pieces are done. Now the glass piece. It could be done by cutting the top part of a sphere, then extruding the border a short distance, and finally duplicating and repositioning at the bottom. Let's take another approach and use the revolve method. In the Create tab, click on the Curve tool. An object named Curve Object 1 is added at the object level, and the cursor changes its shape. Now you are ready to draw the curve points. You can draw polygonal lines, nerve curves, Bezier curves, or points. Let's select the nerves option. Start placing the points. And at the end, hit Enter to finish. To modify the point positions, just click on them and drag them. Rename the object as glass. To create the shape, we are going to revolve this curve around the y-axis. To avoid unwanted results or artifacts, it is important to make sure that the center points are aligned along the y-axis. So their x-coordinates must be 0. We could use the snapping functions, but let's use an alternative way. Dive in the glass object. Now, in the curve node, in the coordinates field, hold Alt and press E. A window opens, and each point is represented by 3 coordinates, x, y, and z. So, for the first point, select the first value and type 0, and apply. Go to the last point, also select the first value and type 0, and apply. Now, both points are perfectly aligned along the y-axis. Go to the object level. Another important detail. If we revolve the curve now, as it is a nerve curve, we will get a nerve surface. So, let's convert it first to a polygonal curve. Select the glass object, go to the Model tab and click on Convert. Now click on the Revolve tool. If we check in the viewport, we need more divisions. In the Parameter tab, increase the division parameter to 120. Okay, this shape is done. Let's do the lens hood now. Go to the Create tab and Ctrl-click on the Tube tool. Relocate the object and, in the Operation Controls bar, reduce its height and set its columns to 120. Relocate the object and change the height and radius to match the image reference. Besides, activate the End Caps option. Go to the Geometry Selection mode and make sure the option Primitives is checked and select the top primitive. Now, in the Polygon tab, click on the Poly Extrude tool, adjust distance and inset. Press Q and adjust the distance and inset to match the image reference. OK, now select the top primitive and delete it. Do the same with the bottom primitive. Go to the object level and rename the object as Hood. Now, to get the final shape, we are going to draw a curve, extrude it and use it as a cutting plane. Go to the front view and hold the space and press B to maximize it. To change the wireframe to see our image, we could go to the Shading Options menu, but it's faster to use the shortcut W to toggle. Tap W. Now we are in wireframe mode. Go to the Create tab and click on the Curve tool. Start placing the points. And at the end, hit Enter to finish. We need curved segments, so change the primitive type from polygon to NURBS. Better, drag the points to adjust the curve. OK, rename the curve object 1 as Profile. Double-click to dive inside. Now, in the Coordinates field, remember, each point is represented by its 3 coordinates, X, Y, and Z. Change the X value for the first point to 0. Go to the object level. Instead of using the shelf dock to convert and extrude, just to practice, let's do it in the network editor. Double-click on the profile object to dive inside. Click on the output port and drag, then press Tab and start typing Convert. As soon as the tool is filtered, press Enter. Done. Change the display flag to the Convert 1 node. As we only draw half of the curve, we need to mirror it in the X direction. Click on the output port of the Convert 1 node, drag, press Tab and start typing Mirror. And as soon as the tool is filtered, hit Enter. OK, now we have the complete curve. With more practice in the network editor, you will realize that this way of working is faster than using the shell tools. The tools' names are also easy to figure out and remember. Nevertheless, working with the shell tools or the network editor, you end up with a node network. The advantage of node networks is that all the instructions or nodes are alive and calculated at any moment. So you can go back to the Curve 1 node and modify the points, or go into the Convert 1 or Mirror 1 nodes and change parameters. The output always will be updated. OK, go to the Polygon tab and click on the Poly Extrude tool. Select the curve. And drag the distance handle. And we have a weird result. Ctrl-C to undo the change. It is because the extrude direction is not aligned with the Z-axis. We could change the curve normals and align them to the Z-axis. But in this case, we are going to force the extrusion direction in the Z-axis. In the Parameter tab, go to the Front Transform section and activate the Transform Extrude Front option. Now drag the handle that is aligned with the global Z-axis. Round the translation to -3. Go to the object level and use the translate handles to center the surface. Change the shading options to smooth wire shaded. To use this surface as a cutting plane, we are going to use the Boolean tool. This tool in Houdini is quite powerful. You can take two sets of polygonal objects or surfaces and do Boolean operations such as union, subtract, intersection, and shatter. Go to the Model tab and click on Boolean. You get a message. Select object for set A. Select the hood and hit enter. Now the message says, select objects for set B. Select the profile object and hit enter. In the Parameter tab, as both A and B objects are surfaces, change the Treat As field from Solid to Surface for set A and B. And finally, in the Operation field, change the operation to Shatter. Go to the object level. You can see the hood object has been shattered by the cutting plane. Go to Geometry Selection mode and select the top primitives and press the Delete key. Nice. Now select the hood object. Go to Geometry Selection mode and make sure the option Edges is selected. Or in one step, just type the shortcut 3 to select Edges. Select one loop and go to the Polygon tab. We are going to use the old Poly Bevel tool. Click the tool, adjust the offset, change the shape to round and the divisions to 4. In this old tool, we don't have the convexity feature. Select another loop and again apply the old bevel tool. Almost finished. We need to add thickness to the surface. Go to the Geometry Selection mode and select all the polygons. Click on the Poly Extrude tool and drag the distance handle to add thickness. Also activate the Output Back option. Let's go back to the object level. And we are done! We have successfully made our first model in Houdini. Congratulations! Let's save the scene. Create a new one and reload the current desktop. Now, to start our final practice, we need a geometry to work with. In the viewport, hit Tab to access the tools. They are organized by shelves or by categories. Go to the Test Geometry category and select Rubber Toy and hit Enter to place the object at the center of the scene. In the shading options, select Smooth Wire Shaded. Go to the Geometry Selection mode, click on the Select tool and in the Operation Controls bar, select Points. Click on a point in the geometry. You can grow the selection by holding Shift and tapping G several times. To shrink the selection, hold Shift and tap S several times. OK, grow again the selection. Now press T. In the network view, an edit node has been added and the translation handles are shown in the viewport. If you drag the Z-axis handle, the selected points are moved. To have a soft effect, go to the Parameter tab and increase the soft radius parameter. Now, the translation movement not only affects the selected points, but gradually affects other points that fall off in the soft radius distance. To select another point and grow the selection, you have two options. The long way, click on the Selection tool, make sure the Points option is selected, select the point, and use Shift-G to grow the selection. But to move them, you have to press T again to get back the translation handles. The most efficient way is hold S to temporarily change to selection mode. Click on a point to select, use Shift-G to grow the selection, and now release the S key to get back the move handles. Move the translation handles. Okay, if you pay attention to the rubber toy, the first editing to the nose is still there, and of course the last edit to the tail. Unlike most Houdini operators, edit is cumulative, and therefore you can store multiple edits in one single node. Because of that, you cannot animate the parameters in this node. We can use deform tools to deform and animate the transformation at the object level. Go to the object level. Now go to the Deform tab. Here you can find 3 deform tools: Twist, Bend, and Linear Taper. The 3 operators are based on a bend node, but with different settings. Let's try the Twist operator. Click on the tool and you will be prompted to select the geometry to be affected. Select the rubber toy and press Enter. And press Enter again to deform the entire geometry. In the Network Editor and the Parameter tab, you can see although the node is named Twist 1, it is a bend node with settings to twist the object. The visual controls for this node have been greatly improved in Houdini version 18. You have a bounding box that covers the area to be affected, an axis that indicates the deform direction, and a ring to control the deformation amount. At the bottom in the viewport, you have the shortcuts to adjust the settings interactively. With the V key, for instance, you can cycle the capture axis. Please experiment with these features. For this example, we are going to do it manually in the Parameter tab. Here you can control the twist amount. In the Capture section, you can change the origin, the direction, and the length of the capture. Set 0 in the origin fields. Now the capture origin is at the center of the scene. To set the deformation direction along the Z-axis, set the X and Y components to 0 and the Z component to 1. Let's twist the object using the ring controller. The direction is okay, but the origin is in the middle of the object. Move back the origin along the Z-axis. Twist the object. Okay, it's better. Now, just for fun, let's animate the deformation using a motion effects preset. Set the twist amount to 0. Now right-click, go to Motion Effects and select Wave. From the previous episode, we already know how it works. Play the animation. The speed is too fast. Activate the real-time toggle in the play bar. The amplitude, on the other hand, is too short. Increase it to 40 degrees, so that the twist will be 40 degrees to the left, then 40 degrees to the right. Play the animation, it's better. Let's reduce the frequency by increasing the period parameter. And to have a perfect loop, make sure the position and direction of the end and the beginning of the curve matches. Play the animation. The loop is okay. Nice. This concludes this video. We have covered basic modeling and mesh deformation. Thanks for watching this video. I'll see you soon in the next one.